Hi guys, this is a short introduction what I would do in the next few videos about underfloor heating and more precise an electric underfloor heating controller. What I could find in Loxone, most of it, and all the examples, most of the examples I found even in internet, YouTube, Loxone documentation was about underfloor heating and the heating system with water, with electric valves and the flow rate and everything, but not much information about electric underfloor heating. Underfloor heating might be very useful if you have a lot of solar panels and you can generate your own electricity. It will be very affordable to do it. In this series I will try to create my own version of the underfloor heating controller for the electric heaters, and this is the block schematic of the controller. What we will have is a temperature sensor input, the intelligent room controller, and temperature sensors into the underfloor heating near to the heater, comparators, flip-flop, and the means to turn on the heating. In this example I had contactors. We start by creating a new page, and we will call it heating. We need to assign a category, again heating, and the room, like always YouTube room. Okay, now in the meantime we save to the server. Okay, press F5, bring down to intelligent, intelligent room controller. Okay, and we go to the temperature sensors. In this case we have the first temperature sensor. Okay, we bring the second temperature sensor. This is in the floor. Okay, in the meantime we save again. The underfloor heating temperature sensor, we need it twice. F5 again. We need two comparators, and in Loxone they call them greater and equal, or equal. Okay, we need two of them, and those ones, they will check the input. Okay, connected and connected. Now we need two text input. Okay, this call it the max underfloor heating temperature, and in my case I set it top 28 degrees. Okay, grab it, and I think it goes here, maximum. Okay, the second one, minimum underfloor heating temp, and this will be 27.5. Okay. Save again. Why do I have 28 degrees only? Because I placed the temperature sensor in my case right here in the middle. That will be the temperature sensor. Okay, and it needs time for the heat to travel. At the time we have 28 degrees in here, near to the heater, the temperature is a bit higher, and depends how thick is your floor. If it's very thin, yeah, the transfer will be faster, but if it's thicker, you need to run it and check if 28 degrees is right for you. At the beginning I set it up 35 degrees, and in half an hour we were boiling inside the house, and some cases you can go even lower. Okay, next, come on, F5, and flip flop, F5, flip flop. Second one. Okay. One connected to set and the other one connected to the reset. In this situation we have the maximum temperature is lower than the temperature read by the sensor, and then it means we reset the flip-flop, and then the output is 0. And in this situation we should have the output to the relay heater controller should be 0. Okay, next step. Because we don't have a digital output on this intelligent room controller, we just have heating and cooling output, which are analog from 0 to 10 volts. For example, now the sensor room temperature is 16.1 and the comfort temperature is 16. If we increase the comfort temperature on the output on the heating, this will change from 0 up to 10. On 16 degrees we have cooling. If you have a AC, you can use that one for turning on the AC if you want. Okay, but for the moment we're increasing the comfort temperature, for example 17, and then the max output is 10. We can't to be able to use it to add a digital output, one of the digital input, digital output, and one of the actuators, the relays, need to be connected in here. You can't just take an output relay and connect it like this. Does not work, because you will have an analog and you need a digital. Okay, in our situation, to be able to make it easy for us, we will use another greater and or equal F5. Okay. heating goes to the A1, and in our situation when the heating is higher than 0, we should have an output. In that situation we need to create another input, and I will call it 0, but it cannot be 0 because these comparators equal or greater, and if I will set it up 0, that would be on non-stop. 0.1, yeah, and set 0.1. Take this into the okay. That doesn't like them. Okay, something like this. Okay, and set the flip-flop. Okay, in the case of you have in the room is still cold, but the underfloor heating reaches the highest temperature, you don't need to keep the heating mat on, and for that situation we use from the first flip-flop to the second flip-flop to reset it. The temperature sensor is reading 15.9, and our comfort room temperature is 17. The intelligent room controller is requesting the heat. Our comparator is translating the value 10 into a digital signal, sending it forward to the flip-flop. Even if we have one on the set, the output is off because we have the reset on. Why do we have the reset on? The reset on is because the underfloor heating temperature sensor is reading a higher temperature than the 28, and then we need to keep the temperature the power on the heating mat 0. Then in this case we have the actuator is off. As you can see now, we have those comparator off. We still have on the reset. In this situation we have to wait until the temperature into the underfloor will go lower than 27.5 degrees. Now we have a lower temperature than 27.5, and the flip-flop is set, removing the reset, and the request for heating is going through, and now we have power through the heating mat. Now the heating mat it's heating. As you can see, the temperature is increasing, and once the temperature is increased, we have reset on this flip-flop. To make it easier, we will do something like this. We make them blue. Okay, and now this will be the blue team. Okay, very good. And these guys, they remain the green team. Okay, now the blue flip-flop, it's resetted, but because we have this output negated and it's opposite, it's supposed to be off but it's on. Now it's resetting the green flip-flop. This situation, our actuator is off. We don't heat up the mat. We have the situation where underfloor heating is hotter than we need, And if we lower down the temperature, the comfort temperature, yeah, we have 0 request going to comparator, is good, but the flip-flop is still on. To avoid these kind of problems, we don't need the heating, but the mat is still heating up. Okay, it will heat up until the mat reaches the 28 degrees, and then will reset itself back, and then will stop. But to avoid having these problems, you don't want the heat but the mat is still heating up, we need to add another comparator. Again, F5. Oh, we have it here. Generate, okay. This one goes to the reset. We need to reset this. We put them nice under each other. Make it a red theme. Okay, I will do it here. Make it nice and pretty. Again, we take the temperature. Temperature sensor. Okay. Save. As long we have a higher temperature than the comfort temperature, higher temperature in the room than the comfort temperature, we have a logic 1 output resetting the flip-flop. And in this situation, if we go back to the web page, now we have the comfort room temperature set it up at 13 degrees and we're reading 14 degrees. Increasing the comfort temperature, yeah, going above 14, yeah, 14.5, this comparator switches it off, it stays off. Now we increase the temperature on the comfort. Okay, in this situation it shows me the underfloor heating is still hot. Okay, the blue flop is off, and in this situation the green flip-flop switches on and start heating up the mat. Once the mat is hot, again the green flip-flop will become inactive. If we go to the web page and the comfort temperature, now we need to lower down. We lower down underneath 14 and everything is off. Increasing, on. Decreasing, off. Now it's reacting very well. If you're using the solid state relays, you don't need to use this flip-flop option. I use this flip-flop option because when the temperature sensor is reaching the threshold temperature, for example, in our case 28 degrees, it's not going straight to 28 degrees and stays there. I had a situation where I could hear the relays switching on and off for a few seconds and then stay on or off, because the increasing or decreasing the temperature is not constant, goes ups and down, and in that situation it's switching on the relay and switching it off. To avoid this situation where the relay is clicking non-stop, we use the flip-flop. But if you're using a solid state relay, that will be no problem, because you won't have any problems with the relay, wear or noise, nothing. That will be alright. Okay. that's it. That's for today's video. I hope this project will be helpful and will help you to set up a future underfloor heating. Yeah, it's quite long, but see you in the next video. Thank you very much.